Hello and welcome to another video. I'm going to take a small break from doing the front end videos and I'm going to do some of these. So if you haven't seen the site before, Hello Interview, I'd strongly recommend it for learning system design. I think it's really good. They have a lot of deep dives and videos they make as well. And they have this kind of thing, which is kind of like leak code for system design, which is a really nice platform in my opinion. So today we're going to be designing Bitly. And so you want to have a URL shortening service similar to Bitly. So I think most people are familiar with Bitly. If you aren't, what it does is it gives you a long URL and then it gives you a shortened version. So you'll type in some long thing and then it'll just give you like a bit.ly.com/ some short thing. You can also provide a custom alias or an expiration and should be able to access the original URL by the shortened URL. So essentially, you go on the site, you put in your long URL, it gives you a short URL, and then when you put in a short URL into the browser, that one they gave you, it'll give you the long one. So like if I put this into Bitly, it'll give me bit.ly/ something tiny, and then if I put that in, it'll basically redirect me here. And then the scale is 1 billion shortened URL and 100 million daily active users. Okay. Yeah, and so if you've watched some of their videos, they kind of recommend this framework, which is pretty nice, I think. So essentially you take the requirements and then you make the core entities, which is like the tables and the data, and then API, like whatever API calls you need to do what you said the requirements were, and then the data flow and the high level design, which is just going to be like a basic, like how do I just get something working, and then deep dives is like, okay, if I need to scale, what's going to break and how do I fix these things. Okay, so it looks like first thing they ask is what are the non-functional requirements. So they do tell you the scale already, so I guess that's a non-functional requirement. So support lot or one, yeah, I guess we can literally just copy this, basically the scale. So I think they use Excalibur as well in here. So let's see, okay, let's just write it again. Okay, so support 1 bill or store 1 bill URLs and have 100 million daily active users. So probably have like fast redirects and fast short URL responses, something like that, because you have a lot of daily active users here. So like 100 million daily active users, I think there's like roughly 100,000 seconds in a day. So that's like 1,000, yeah, that's like 1,000, I guess, or is it 1,000? Let's see. So 100 million is 10 to the 9th, 100,000 is 10 to the 5th. So it's actually like 10,000 queries per second, I guess. And so that's another thing I'd probably recommend is like these that I learned is like figuring out the seconds in a day quickly. So basically you have like 24 hours times 24 hours, or sorry, times 60 times 60. That's how many seconds you have in a day. So this is like 24 times 3,600. And then if you just like calculator this guy, so you get 8,600 seconds, and then you basically want to round, like for all these things, you just want to round to make your math easy. But yeah, essentially, so support, I guess, yeah, 10K queries per second. Okay, and then let's see what else we would want. Okay. Oh yeah, by the way, so non-functional requirements are like this is actually what you need, like the product requirements, and this is like the infrastructure requirements type of stuff. Okay, and they do give you some like hints here, I guess. So yeah, so availability versus consistency is basically like, if as you scale availability, you lower consistency. So for cap theorem, you have availability, consistency, and partition tolerance, and basically all of these are like a distributed system. So you're gonna have partition system and everything. So the P is always there, and then you basically just figure out, do I want availability or consistency? And availability means like your service is always up and responding as quick as possible. And consistency means as soon as I write some data, the next person who reads right away should get that fresh data. And most of the times that's not super needed. Like most of the time consistency isn't super needed. It's mostly needed for like things with like money usually. So like trading systems or banks or things like that. And there are some other things, but for the most part, it doesn't really matter. Like Like, let's say for most systems, if someone, sends you a text or writes a post or whatever, you don't need to instantly have it when you like if someone's on Twitter and they write a post and you go on Twitter right away, right after, and you don't see their post immediately, like it doesn't matter. You're not even going to know that, right? So most of these don't matter. So in this case, like if you think about the user experience here, so they go on Bitly. I guess we can even show this. So if you go on Bitly and you put in a URL, like think about like what that's gonna look like. So you're gonna put in a URL, you're gonna get a new URL, and then you're gonna share it with someone, and that's gonna take a while. So it's fine to like when you give them a URL, if someone else tries to put in that URL, it doesn't work right away or something like that, or it's not there or whatever. So here we don't really need to prioritize consistency, so we can prioritize availability of service. And then the only thing we do need to make sure is we don't have duplicate short URLs. So that would be a problem, right? Like let's say I put in this guy and someone else puts in something else and we both get bit.ly, /123. That would be a problem. So as long as you don't have this, like the availability is fine. You don't need to have this thing straight away. Okay, and then I think you can click get feedback. I think I did part of this one before, so let's see what happens. Yeah, I'm definitely not as good at system design as I am at LeetCode, so we'll see. Quantifying low latency, for example. Oh yeah, so this latency thing, so another thing I learned from this latency thing is, so typically if you have like 200 ms latency or less, that looks like instant to a person. So I guess we can try to have that. So like have 200 ms latency for redirect or something like that. Okay, and try again, I guess. Okay, and then move to the next one. So yeah, the core entity is basically like the tables or things like that. And then here they also don't recommend, and I think it makes a lot of sense, they don't recommend going super in depth into the tables. So just have a rough idea of like what you need, and then as you build your system, you can then figure out like what exactly do I need in each table. So making, the couple things that they don't recommend is going super deep into these tables and also doing a lot of calculations up here, like this, figuring out this QPS and all that. Usually they don't recommend, because what usually ends up happening is people do the like the person doing the interviews is going to tell you some big number, so they already know it's going to have a lot of users, and then someone does a calculation and then they realize, oh hey, I need a lot of users, so I need a distributed system. And it's like you're already doing a distributed system design interview pretty much, because like every system design interview almost is distributed. And then sometimes you will get a diagram, and then you will do the calculation and you realize like, oh, it can fit on one server, one database. So but you could do that at the end, like once you worry about the scaling issues. So in this case, I feel like we can have something really simple. We can literally just have like a short URL table with a map of like short URL, long URL. Yeah, that's basically it, to be honest, and like the expiration date, update, and like whatever. So we can have a table of short URL that includes short URL, long URL, expiration date, and stuff like that. And then maybe we have like a user table of like user data, like user metadata or whatever. So yeah, this is probably going to be like one of the easiest core entities, because it's literally you just have a short URL and long URL. All right, let's see this. Okay. Main API endpoints. Okay, so for this thing, what they recommend here, and it makes a lot of sense, is you look at your functional requirements and you ask yourself like, what APIs do I need here? So it says user should be able to submit a long URL and receive a shortened version. So like you just think, okay. And then for most of these, I just use REST, because that's what I'm familiar with. I guess you can use like GraphQL or some other stuff if you're familiar with that, or if you think there's a use case, or you can talk about that. But yeah, so if you submit a long URL and receive a shortened version, basically you want to think like, okay, what kind of request is that? It's obviously not a GET. It's not a put or patch. We're not patching. We're essentially creating a new thing. So it's going to be a post. And then the endpoint we can use here. So for post, typically you have like a plural of whatever thing it ends with, so we can call this like URLs. And then we will return a short URL, I guess. So short URL, return short URL. And then in this post request, so yeah, typically if you make a post, you would just say like in the body of the post, what will you have? And so this is pretty easy. So we can have a long URL. We can have, let's look back up here. So submit a URL, and they can also optionally include custom alias and expiration. So we can include those. And yeah, so yeah, the way they do these is usually they write it in like TypeScript format, and I like that as well. So essentially we can do something like that, like JavaScript, TypeScript format. So we can say like we have an alias that's like question mark, so it's like optional, and then we'll have a expiration, like date or whatever, and that's also optional. Okay, so that's gonna get like 1 and 2 are basically done here, and then they should be able to access the original URL by the shortened URL. So access is going to be a get. So get, and then yeah, you can figure out like what exactly endpoint you want here. So typically you can do this in a bunch of ways, but we can say like the ID, like if you want to do a get by ID, you can say the ID is going to be the short URL here. Or we could do like URL/short URL or whatever. But yeah, so it's usually like this, I think. Usually it's like post, you have like some name here. Actually, yeah, you can do one of two ways. You can do this as well. It's fine too. So yeah, get, so this is basically a get by ID. So get, you typically have a get by ID or like a get all. This is not a get all, this is a get by ID, so we can have it like this. And what this will do is it will basically, see, click. So this will redirect us to the long URL. Okay, so essentially, yeah, you can have a server response that is a redirect, and you just pass a status code for that. So this will be like, forget exactly what it is, and I think I have done or looked at this before. So I think there's basically two ways you can redirect. So you can redirect to a URL and then cache it, and then every time they put in the same GET request, it will just immediately like return it. Or you can redirect and not cache. So I think it's like 301 versus 302. Yeah. So 301 is permanent. Web page is permanently moved. 302 is temporary. Page is only temporarily moved and will eventually. Yeah. So 301 is basically like cached. And so the upside of a 301 is, so whenever they call a GET, this is going to hit our service. And with a 301, we're basically going to cache our response, so we're not going to need to hit our service all the time. So let's say some really popular URL gets shared, like Super Bowl or whatever, and everyone's just like spamming this URL. This will just immediately avoid. Well, actually, no, that's not true. Sorry. So if everyone's spamming this URL, this won't help us that much. What this will help us with is if a user is using that URL a lot. If everyone's spamming the URL, it will first take them to our service anyway. So it's not going to help that much, because if you think about it, like if someone shares a bit.ly with someone else, that other person isn't going to use it a lot. They might use it like once or twice. So here we probably want to just redirect with a 302, because we're not really saving that much, and also we can't track like user metadata as well, or like, you know, how our service is working. Because yeah, I guess that's the main thing, because if they skip our service a lot, we can't track how our service is working. But if we know for sure our service is working and we are actually happy with like the number of requests we're getting, then we can do this as well. Because let's say a person accesses a bit.ly 5 times and we're okay having them access it once, then we can just do this. All right, so let's see here. Okay. All right, post could be renamed to short URLs or shortened URLs. Simplifying GET, short code. Response for the post. Oh yeah, so I guess, I feel like that's kind of obvious though. Yeah, we would just return some data with like long, or actually short URL here. Like that would just be the body of the response. Yeah, I guess that's kind of obvious, or I guess it would be like this. Okay, and then as far as like the what the endpoint is called, that's whatever. Or yeah, like that can just be like how you're designing your APIs. I don't think that matters too much. Okay, so I guess we can change this. Return. Whoops. Put it in here. Okay. And then yeah, so I guess we can take their suggestion, even though I don't think it doesn't matter much. So we can just go like this if we want to. This can be like our standard, and then post will be 2 URLs or short URLs or something. Yeah, I don't know how much that matters either. Okay. Okay, we'll just leave it like this. This will be fine. Try again. Yeah, I think these responses like aren't super, yeah, super meaningful in this case. Like they're not that bad. Okay, but whatever. All right, moving on. How will users shorten a URL? Don't worry about algorithm. Okay, so users should be able to shorten a URL, spend 5 minutes, draw a system, start simple. Okay. Okay, and they do have like an example here of like some stuff. So essentially, we're just gonna start like really simple. So we'll have a client. Okay, I think we need to zoom in some more. Okay, let's see if I do large client. Okay, this is good. Okay, so we'll have a client, and it will call our service. So and it will basically right here, we're gonna post long URL. And then this shortener will create a short URL, store it in the DB. So create, or actually we'll write it right here. So create short URL, optionally with alias given, and yeah, I guess we don't need to write that because that's already like inner requirement, so we don't need to say like the exact thing there. So we'll create a short URL here and then essentially save it in the DB, and then we will have an arrow back. Okay, so basically long URL goes here, or like yeah, actually this will be like short URL goes here because it'll be created and then it will be sent back. And then we just send it back. So as simple as it can be, literally like this. Okay. Okay, yeah, we don't have to write it because we can just like, so in your system design, you can just talk about like what would happen. So I think we don't even need this, to be honest. Just get rid of all that because this would be the data flow. So we can say this, and then yeah, a relevant schema would be the short URL table with long URL row or column, and like expiration column or something like that. Something like that. Okay. So, all right. So let's talk about that, I guess. And this is also really nice because you can just say it and then it will give you like a response. Or you can do text, but let's try this one. Okay. Oh. Okay, so what we're going to do is the client's going to send us a long URL and a post request, optionally with an alias and an expiration date. That's going to hit our shortener service. And then our shortener service is going to use some algorithm to make a short URL. And if they provide an alias, maybe we'll try to use the alias if it's available. And we will also try to, if they provide an expiration time, we'll add an expiration time in our expire column. Otherwise, we can have like expire null or some default expire time, maybe expire in 6 months or something like that. And so we're gonna make a new row in our DB in our short URL table with the short URL primary key, the long URL they provided, and then the expire, depending on, like I said, if they gave one or we have some default or whatever that is. And then we will return the short URL to the shortening service. Or actually, we don't even need to do that. We don't need to even return the short URL from the shortening service. I guess we just need to wait for this to be done. The shortener service will already have the short URL, and then it can return to the client. And that's it. Okay, so let's see how this goes. Okay. Okay, get feedback. Okay, cool. So provided clear. Consider adding a short URL column in the short URL table to explicitly store the generated short URL. Oh yeah, I guess I didn't write that, but I mean, I talked about that. So short URL primary key here. Okay. Yeah, we'll just move on. Okay. How will users be redirected from a short URL to the long URL? Okay, so it's going to be similar data flow, except now we're not going to hit the DB. So it'll still be kind of the same. But basically, let's just talk about it, I guess. Okay, so what's going to happen is the user will make a GET request from the client to the shortener service. And they're going to provide the short URL in the GET request. And then, actually, yeah, we will still hit the DB. So the shortener service will hit the DB, and it will check what's the long URL associated with that short URL, because we have a table. So we can just do a query here, like get long URL associated with a short URL. Short URL is a primary key, so there should only be one row there. If it doesn't exist, we can throw an error or something like that. So yeah, basically we're going to get the long URL back to the shortener, and then the shortener will send back the long URL along with a 302 redirect. So yeah, there will basically be a redirect, and then the client can redirect to the long URL. Okay. Okay. Adding access count column to track the number of times. Yeah, that does make sense as well. For metrics, that's probably a good idea. So here we could have an access count column. Because then we can track like what URL is used the most. That makes a lot of sense. I mean, we can add other columns here, but this isn't like super necessary to the service, I guess the core parts of the service. You can add a bunch of other stuff like update, or I guess not updated, but yeah, a bunch of other stuff you can think of, but this is like the core stuff that you need. And so we're gonna move on. Okay, deep dives. Yeah, so the deep dives here is basically like, as your service scales now, how do you improve things? All right. Okay. So how do we ensure that each shortened URL is short and unique? Okay. So I guess we can call this like URL shortening algo or something. So here first we would determine we would ask what people think is short, or do we just make this as short as we can? As short as we can. So one thing you could do that would be kind of bad is use the long URL, and then if you use the long URL, let's say we have google.com/whatever, and we just take the first 20 characters of the URL, or the last 20 characters or whatever that is, and we make that a short URL. So let's say our short URL is 10 characters, and we just say let's just take the first 10 of here. So hopefully you could see why that would be bad, because you're going to have a bunch of these google.com URLs, and then you're not going to, you need to find a way to create a unique short URL. And if you didn't create a unique short URL, you're going to need to find a backup to keep doing it to create another unique short URL. So this would be kind of bad. So I guess good solutions. So we could basically just generate a random, we want to make it as short as possible. So I think in Bitly, you use uppercase characters, lowercase characters, and like numbers, or yeah, we can, yeah, basically do something like that. Or even more characters, like we can take everything up to like the top 100 ASCII. So if we go like ASCII table here, yeah, so we can essentially do something like that where we can use like all these uppercase, all these lowercase, and then numbers. We probably don't, yeah, I guess we can't really have like an escape, or so these wouldn't work. And then we don't want to have like spaces and this kind of stuff in a URL. So probably the best thing is just to have like uppercase, lowercase characters and numbers. And you can actually do that. So you can actually just base, I think it's like base 64 or base 62, base 64 encode something into that. So base 64 is kind of simple. Like if you think about it, decimal is base 10, binary is base 2. So base 64 will just be more compact, right? So if you have some number, like, you know, like a million or whatever, it will just make it more compact because it's base 64 instead of base 10. So what we can do is we can basically we have to figure out a way how to actually make a new key that's not reliant on the URL, and then we have to essentially base 64 encode that key into something. And so what we can do is we can basically just make a random number. That would be like okay, I think. And then we just have to determine like how big the random number has to be so we don't have a lot of collisions. So if we have a billion URLs, if we have like, let's say we use like a trillion or something like that, like we just make a random number from like 1 to a trillion, and then we can base 64 encode that, and that won't be that many, that'll be kind of short. And then we just have to check, like, is our base 64 encoding in here already? If it is, let's just get another one. So if we do base 64 encoding converter, and we put in like a trillion. Okay, so how many characters is this? Is 3, 4, 5, 6, 7, 8, 9. I think this is like more than the trillion actually. Let's see, 3, 6, 9, 12, like 14 or something. Okay, what if we do a billion? So 9 zeros. Okay. Yeah, and I guess keep in mind that like, so this will take this amount of space, but if we make this like all 9s, it won't be that much bigger. So if we go this, yeah, so we can use like really big numbers here, and this isn't that big of a URL. This is like, let's call it 10, you know, whatever, 10 letters or something. So that seems pretty reasonable. So I think we can do something like that where we can basically base 64 encode. So what we would do is the step would be generate a random number, 1 to a trillion, I guess, or I guess it would be like bigger than a trillion. It would be like or I guess, yeah, so we can do 1 to 1 trillion, I guess. So it would actually be less than a trillion. It would just be like a bunch of billions or whatever. And then we want to base 64 encode it. So actually, maybe thinking about this, maybe this wouldn't be the best, because like we don't really want to generate like 1, but we can also solve that where we can generate a random number like 1 billion to a trillion or whatever, something like that. That would be fine. And then our number would always be in the billions. So something like this. So we generate a random number, then base 64 encode that number to make it shorter. And then we would check db if this exists. If yes, make another one. And so we just keep making another one until it doesn't exist. And we're not going to have that many collisions. Like if you have, you know, if you generate a random number from a billion to a trillion, like your collisions aren't going to be that common. So you might have a couple, but it'll basically be fine. Yeah. So you could talk about like how short the URL has to be and so on and so on. And so we can also figure out like let's say we have like an 8 letter base 64. So that would be like 64 to the 8th, which would be actually really big. Yeah. Yeah, so I guess another thing we could do instead of generating a random number is we could just generate like a hash and then convert that hash into base64 encoding as well. That seems pretty reasonable to me. So we generate a hash that's like all, like longer, like maybe it only has letters or something, and we convert that to base64. But I think I'm going to stay with this one. I don't want to focus too much on like the URL shortening algo thing, but I think this is like pretty reasonable. So essentially we just do something like this. Okay, so let's go with this. Okay, so yeah. Okay, so what we're gonna do is, first of all, we're gonna discuss like how short does it need to be, and then basically what we can do is we can just generate a random number, and then we can base64 encode the number to make it shorter, and then we can check if that base64 encoding exists in our database, and if it does, we'll just keep doing this until we get a new one. But if it doesn't, then that's going to be our short URL, and then that's what we're going to be returning. And base64 should be able to make it reasonably short. Okay. It's valid. Instead of using random number, you could implement a global counter with base62. You get uniqueness. Consider specifying the exact range. Okay. Okay, so this makes sense. Yeah, we could figure out like how likely it is for a collision and stuff like that. Okay, I think so you could have a global counter, but the problem with the global counter, like you could do that, but the problem with the global counter is if you scale your service, you're gonna have to make sure your global counter is in sync. So there's like difficulties there. So here we can have retries, but as long as there's not too many, we don't have to worry about having our global counter in sync with like all our services or all our, like, if we scale this more. But with a global counter, we won't have to keep checking, but we have the other error. So I guess there's like ups and downs there. And the exact range I already did specify, so no, that's that. And then yeah, retrying. So here we could do something like basically monitor the retries, and then if the retries are problematic, then we can rethink our algorithm, right? So we can like have this running, we can like monitor the number of retries, like for every single call here, how many times did we have to retry making a new thing? We can just monitor that with like a simple monitor. Yeah, and then from there, like make something better if needed, or make slight adjustments or something like that. But yeah, like I said, I don't want to focus too much on the actual this part of this. All right, so let's move on. How do we ensure that redirects are fast? Okay. Technical. Okay, so yeah, I think I was saying if we have like 1 billion queries per day, I think we said something like 10,000 QPS. Yeah, I mean, we can check the math there really quick. So if we have 1 billion over 100,000, maybe I did it wrong. Yeah, 10,000 QPS. Okay. So, but there might be peaks here, right? Like let's say that in a peak there's 100,000 QPS, and I think we can't handle this in like one instance of a shortener. So basically what would happen is like if there's some super popular like hot URL or whatever, and we get 100,000 QPS, then this will not work. So how do we make our redirects faster? And also, like, our process here is we go from the client to the shortener, then we have to get the thing from the DB, and we have to do this all the time. So in particular, with like let's say there's some super popular URL, we'd have to do this all the time. So one thing to make it faster is we can have a cache. And I think typically you can just use like Redis or something. So you can have a cache here, and what would happen is our client would call our shortener, and then our shortener would call our cache. And then if our value is there, then we can just return it. and if it's not, it's going to write in the DB. It's going to get it from the DB, and then it's going to update the cache. And then we can just have like an LRU cache or whatever. It's fine. So the least recently used cache, we'll have some size here. I think this can hold a lot because like the data we have is so small. Like we just have short URLs, or actually, I guess we have long URLs, but still, like long URLs might be like 100 bytes or something like that, which is like relatively short. But this is still kind of problematic. So even if we have this cache, yeah, I mean, it will be faster because it will be like if there's a hot URL, it will just get it all together. Another thing we can do is we can batch requests, but I don't know if that's super needed here. So we can basically say like every 100 requests, we'll just combine everything that's the same. Actually, yeah. So this redirect will actually take a short URL, not a long URL. So these will actually be small. And then yeah, we can batch requests and basically say like for every 100 requests or something, if 80%, like 80 of them are one thing, we can just return that immediately to all of them. But also having the cache will also kind of like make that not that bad. But still, this is like a ton of requests, so we probably want to. I guess what we could do is we can separate this out into two services. So we can just say we have this cache, we have a shortener service, and then we can also have another service that's the redirect service. And so this is really common. Here, there's going to be a lot more reads than writes, right? Like if you think about it, like how many short URLs are you making? And in most distributed systems, like there's going to be a lot more reads than writes. So there might be like 10x reads here or 100x reads compared to writes. So out of this 100,000 queries, or whatever, there might be like 90,000 or even more, or 95,000 reads. So yeah, basically we can have a read service here. And then what would happen here is the client would call. So let's actually get rid of this for now. So what would happen here is the shortener would always go this way because you're never going to have that cached. Like this is just like a post request, so you're never going to have that cached. But here, the client can call the read service. The read service can call the cache and see if it's there. If it is there, we can just return right away. So this will just return right away. If it's not, then we are going to write into the DB and then, or read from the DB, get a response, and then save to the cache. So I think, I forgot the name of this, like what kind of cache update policy this is. I want to say it's like a read through or something. Let's take a look. Through cache. Cache will load it, return it. Application, the cache checks if data is available. If data is not, cache retrieves from the database. Cache stores the data. Okay, so it looks like the cache is retrieving from the database. Yeah, I think you can do something like that, but I guess I'm not going to talk too much into details of like the exact cache policies there. But essentially that's what would happen here. And now this read service, we can just like scale it, right? So we can just like make 10 of these horizontally scaled. And then this will be still fine. Okay. Yeah, so let's just, I guess, see how we do there. So what we can do is we can introduce an in-memory cache with Redis, and we can also split our services into the shortener and the read service. So because at peaks, we have on average 10,000 QPS, but on peaks we might have like 100,000 QPS. So, and this is going to be mostly reads. So by splitting the shortener and the read service, we can basically scale the read service horizontally, and we can also have the cache where we don't have to do database lookups for most redirects. Like if we have like a hot URL, it will just keep reading from the cache. And then, yeah, essentially this will kind of solve most of our scaling issues here. Okay, let's see what we did there. Solutions, but okay. Consider explaining the cache eviction. Handle cache misses. Yeah, so I guess I didn't mention that, but I did talk about that. So yeah, basically what would happen if a cache miss happens, we would essentially just read from the database and then update the cache. I think the cache can, yeah. So if this is a service in itself, like let's say this is like a server, this can essentially just do it for you, right? So what you can do is you can, yeah, I guess we can add that in. So we can even say that. So instead of this even going here, we can also read directly from the database. Yeah, I don't know how to make a circular arrow actually. Oh, disaster. Okay, let's get rid of that. Let's see, arrow. Yeah, I don't know if you can. Let's find out. And you just go like this or something. Okay. So yeah, I guess this read service will never interact with the database, and then we can just do this. And that, I think, is better. Okay, so we can go something like this. Okay, so let's redo that. Try again. Switch to voice. Okay, so what we can do is we can have a cache, and we can also split our read service and the shortener. And that way, our read service is going to be the one that needs to scale mostly for these like redirects when there's a lot of traffic. So what we can do here is we can horizontally scale the read service, and then we can have the cache, and then the flow of data is going to be client calls read service checks the cache. If the data is there in the cache, then we can just do the redirect quickly. If it's not in the cache, then the cache can actually, if it's its own server, can just call the database, get the short URL, update itself, and then return to the read service. So the read service never has to call the database directly. And then we'll have LRU eviction for the Redis cache. Performance, reduce latency, cache consistency. Okay, so yeah, I guess as far as cache consistency, we can fit everything in one cache, so there shouldn't be any cache consistency. Because yeah, like a Redis cache is gonna be able to, like all we have is short URL, so you have like 1 billion. So let's say we have 1 billion short URL stored in this cache. Short URL might be like 10 bytes times 1 billion, so it'd be like yeah, like let's say 10 billion bytes. And so we have kilo, mega, giga, so this is like 10 gigabytes or something in the cache if we have all short URLs, which is like easily enough. So we'll never have a consistency problems or anything, I don't think. Okay. Because yeah, this won't be distributed. Like you're never gonna have consistency problems if you have like one computer. So moving on. Yeah, so I guess we kind of did this. So 10K redirects per second. Okay, yep. Yeah, so I guess I kind of talked about that already, but essentially we can do it again. Okay, so with 10K redirects, maybe 100K redirects, when they're in like peaks. Yeah, so I kind of already talked about this, but we can horizontally scale the read service. So that way we can just like infinitely horizontally scale as much as we need. And I think an average server can do like 1 to 10K, I want to say. We can look into this later, requests per second. And because these requests are so simple, like the data is so tiny, I'm going to say it's on the high end. So we're not going to need too many replicas here, or I guess like horizontally scaled servers. But essentially, yeah, we can store everything in one cache, and all our horizontally scaled read services can read from the cache, so we'll never have consistency issues, because we can just store 1 billion. We can store 1 billion URLs in our cache like quite easily. It's only 10 gigs, and yeah, so we can just basically keep scaling this read service, keep scaling this horizontally scaled read service. It's going to call the cache to make it faster. The cache will use a database, and then also I guess for the database, just to make sure, or I guess they didn't ask, so it's good. Okay, so let's see how we did there. Okay. Read service instances that might be needed. Yeah, so like I said, I don't think we're going to have data consistency strategies. Now, the one thing I will mention is if this goes down, but I don't think Redis goes down very often, then we're essentially going to have to like, it's going to be a little bit slower for a while because we won't have a cache, so we'll have to build the cache back up. We could have like a replica of the cache, I guess, if we wanted to, for like safety, but I think we don't really need it. I think it'll be fine like this. So let's move on. Yeah. Okay. Move on. So takeaway requirements API. Okay. All right. So let's read the solution. See if we did anything badly. Functional. Non-functional. Okay. Availability. Scalable. Okay. Original URL, short URL. Yeah, I think you just have this in one table and user. Okay. Yeah, so you can just use a REST and a pretty simple post and a pretty simple get. High level. Okay, yeah, about the same. I guess we also didn't mention the expiration time. So yeah, I think that part I can briefly mention. So I guess what we would do there is whenever we query something and it already expired, we can just like make a new one. And then as far as the cache, you can just add a time to live to the cache. So you can see like how long does it take before it expires. And then, you know, you can add a time to live there. So let's say it expires in like 30 minutes from when you query the database. You can add like a 30-minute time to live to your cache entries. And Redis has that. Users should be able to. Okay, this is good. Temporary and permanent. Okay. Deep dives, short URLs are unique. So bad solution and long prefix. Random number generator, which is I think what I was saying. Yeah, random number and then base 62 or base 64. Okay. Oh, this makes sense. Yeah, so you want to use base 62 because you don't want to have plus and the slash. So base 62 is better for URLs. Okay. Counter. Okay. Yeah, and yeah. Okay, so yeah, I don't know. Maybe the thing I was using was like incorrect, but yeah, basically like a billion in base 62 is like six characters, so that's fine. Redirects are fast. Add an index. So I didn't talk about adding an index, but you automatically have an index on your primary key, and our primary key is a short URL, so it's already going to be there. Cache, and then leveraging CDN and edge computing. Okay. Yeah, usually you don't want to have, I think, CDN as a cache, but I guess if you only, yeah, that would be kind of weird because you have a bunch of CDNs and you have to keep them consistent, but maybe it'll work because you don't have to actually have to update the cache too often. Like even though we had an eviction policy, you almost never have to evict. So, okay, and then, oh yeah, how do we support? Yeah, I don't know if I talked. Yeah, so the size of the database. I didn't really talk about it, but yeah, basically you can do this calculation. So long URL is like 100 bytes, and then short URL is like 10 bytes, and then the other stuff might be another like 100 bytes. So if on average a row is like, let's say 500 bytes, and we have a billion of them, this is how many bytes. So if we divide by 1,000, so many kilobytes. And then divide by 1,000 again, megabytes, divide by 1,000 again, how many gigabytes? Yeah, so it's 500 gigabytes, so we can easily just have that on one database instance. We don't need to like do anything complicated. And yeah, I didn't talk about, I guess, the database we pick, but I would just pick Postgres. I mean, it's a pretty simple database we need anyway here, so yeah, I'll just go with that. Okay, so yeah, so these global counter, which I guess makes sense as well, and then they can split the read and the write service, and I think this is good. And then you have a cache, and the read just, yeah. So I think the other thing is, yeah, you can have the cache just talk to the database directly and avoid the read service. Okay, so I think we got most of it. I'm pretty happy with it. And yeah, I'm going to do some more complicated ones. This was definitely an easy one, but I still missed some stuff. So definitely would recommend this one, and I'll do more in the future. So thanks for watching.